So now moving for the last set of questions into chemical reactions. So we've got sodium bicarbonate and sulfuric acid making CO2. Well, of course, sulfuric acid and sodium bicarbonate actually makes sodium sulfate and hydrogen carbonate or carbonic acid. Balance those. We've got to have 2 of the sodium bicarbonates, 2 of the carbonic acids, but then of course carbonic acid also goes further to make CO2 and H2O. So there's the final equation that we need. Nice little bit of acid neutralization. So we know that we start with 0.2 moles of sodium hydrogen carbonate. So the first thing that we have to do is figure out, well, how many moles of CO2 is that going to give us? Because we've got the chemical equation that relates moles and moles. Once we've got moles of CO2, it's going to be readily easily to convert that to volume in this case, because we know the temperature and we know the pressure using PV equals nRT. So I like to set this up using the roadmap. Go back and see the big stoichiometry module if you're not sure with this, but it's fairly straightforward. Once you've got moles of one thing, you can convert it to moles of another thing, and then you can do with that as you will. In this case, we got moles of CO2. We want to turn it to volume. So step 1. It's going to be moles of the NaHCO3 to moles of CO2. What we see is that the ratio is 2 to 2. It's a 1 to 1 or 2 to 2 reaction. So therefore, if we have 0.2 moles of NaHCO3, that will become 0.2 moles of CO2. So we got 0.2 moles of CO2 from the reaction. Now we will just convert that to the volume of CO2 using PV equals nRT. Pop everything in that we know. The pressure, 98.7 kilopascals, so 98,700 pascals. The volume we don't know, 0.2 moles, are 8.314 pascals, cubic meters, moles Kelvin. Punch all that out, and that tells us the volume, 5.1 times 10 to the minus 3 cubic meters. Last couple, a bit more complicated. Airbags, following reaction. What mass of NaN3, so we're asked about grams of NaN3 needed to provide 75 litres nitrogen gas. So we got volume, temperature, pressure of a gas. Where if we're given information about one thing, asked for another, I like to use my roadmap. So let's see what we got. We're starting off with pressure, volume and temperature of a gas, particularly a nitrogen gas. And we're asked about grams of NaN3. So we go from pressure, volume and temperature of the gas to moles of the N2. Use the balanced chemical equation to get moles of the NaN3, which we can then turn into the grams. So step 1, ideal gas law. Volume of N2 to moles of N2, PV equals nRT. We got 1 bar is the pressure, 75 litres is the volume. We want the moles, temperature 298, and 0.08314 litre bar per mole per Kelvin gives us moles, 3.03 moles of N2. So this part here going from the volume, pressure and temperature up to moles, 3.03 moles of N2. Now we got that 3.03 moles of N2. We now do step 2. Step 2, we got moles of N2. We want moles of NaN3. Again, it is a 1-to-1 reaction, which is nice. So the moles of NaN3, 3.04 moles. Once we got 3.03 moles, excuse me. Once we got 3.03 moles here, very easy to convert it to grams. In step 3, grams is moles times molar mass. Molar mass of NaN3. Well, 3 times 14 is 42, plus 23 is 65, and so we get 197 grams of NaN3. So finishing off with a fun one, beginning with 84 grams CH2, 18 grams water, how much H2? So we'll start off by saying, hey, we're given information about one substance, asked about another one, so that's a roadmap problem. But then we're actually given information about 2 things, both calcium hydride and water. So therefore it is a limiting reactant problem. Again, if you're not sure about this, go back to the big module on stoichiometry. So in my hands, the way I do a limiting reactant problem is I say, well, I've got this and this. Let's see how much H2 I can make from this much calcium hydride. Let's see how much H2 I can make from this much water, and whichever gives me the smaller amount of H2 is the limiting reactant. So we'll start off with the calcium hydride. We've got grams of calcium hydride. So therefore, anytime you've got grams, we'll turn it to moles. Once we've got moles of calcium hydride, we can get moles of the other substance, which in this case is, of course, H2. Okay, so we're starting with the calcium hydride problem. So step one, we've got grams, convert that to moles. Molar mass of calcium hydride is 42 grams per mole. And so that tells me that I have 2 moles of calcium hydride, so 2 moles of calcium hydride. Now in step 2, I'll find out how many moles of H2 I've got. So I set up the ratio from the chemical equation. Moles of H2 is 2 for every 1 CaH2. So I've got 2 moles of calcium hydride, multiply it by 2 to give me 4 moles of H2. So I have enough calcium hydride to make 4 moles of H2. Now let's back up and do the same thing with water. Got 18 grams of water, that's 1 mole of water. From the chemical equation, 2 waters make 2 H2, so it's a 1-to-1 reaction, equivalent reaction. So if I have 1 mole of water, I will make 1 mole of H2. So now let's put that together. I've got enough calcium hydride to make 4 moles of H2. I only have enough water to make 1 mole of H2. So I'm going to make 1 mole of H2. That wasn't the question though. The final question was how many liters at STP? Well, at STP, 1 mole, which is what we got, occupies 22.4 liters. So calcium hydride in excess, water is the limiting reactant, enough water for 1 mole of H2, which at STP, along with any gas, 1 mole occupies 22.4 liters.